Hello students, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Today we are going to discuss the next topic from the chapter, the atoms and molecules, which we have started since this week. So let me just write down the title for the topic. The name of the chapter is Atoms and Molecule. The name of the topic for discussion is what is an atom? What is an atom? Okay, just before that, let's have a quick recap of yesterday's session. We are going to solve in the yesterday's session. If you remember, we have seen the laws of chemical combination, in which I have discussed two laws with you. That is, first law of conservation of mass, and second law was law of constant proportion. So the same examples questions for the yesterday's session we are going to have. So that will be a kind of recap. So first question I will write down. In a reaction, 5.3 gram of sodium carbonate, 5.3 gram of sodium carbonate reacted with 6 gram of ethanoic acid, 6 gram of ethanoic acid. The products were the products were 2.2 gram of carbon dioxide, 0.9 gram of water, and 8.2 gram of sodium ethanoate. Sodium ethanoate. Full stop. Show that the reaction obeys law of conservation of mass. Law of conservation of mass. For that purpose, we have to write down the balanced chemical equation for this reaction, right? What is the reaction? Can you see here? Sodium carbonate is treated with ethanoic acid, right? Okay, let us write down the reaction first of all. The balanced chemical reaction. Sodium carbonate is nothing but Na2CO3. Okay, it combines with ethanoic acid. Ethanoic acid is nothing but acetic acid. The formula for acetic acid is CH3COH. Okay, and the products of this reaction are carbon dioxide plus water plus sodium ethanoate, right? That means a salt, CH3COO Na, right? This is the balanced chemical equation for just a minute. Just let me check. Sodium carbonate reacted with ethanoic acid, yes, correct. Gives you carbon dioxide, water and sodium ethanoate. Yes, so for the balancing purpose we are going to put 2 here 2 here, then this is a balanced equation, right? Can you see? So here also there will be 2, right? So let me just check if the equation is balanced or not. So for that purpose, so elements, number of atoms on left hand side, that is reactant side, and number of atoms on right hand side. Let us start with Na. Okay, Na on the left hand side is 2, right hand side is also 2. Then C, carbon on the left hand side is 1, 2, 3, 4, 5. On the right hand side it is 1, 2, 3, 4 and 5. Okay, then next is oxygen. Oxygen on the left hand side is 3 plus 4, 7. And on the right hand side it is 4, 5, 6 and 7. Yes, so just this balancing is not required. Okay, so oxygen on the right hand side is 4 here, 1 here and 2 here. So 4 plus 1 plus 2, that is equal to 7. Okay, and then let's check for hydrogen finally. Hydrogen on the left hand side is 2 plus 6, right? That is 8. On the right hand side it is here 2 and here 6, that is 6 plus 2 is 8, right? So that is, this is a balanced equation, right? Equation is balanced. Okay, now after that let us just see I'll again write down this equation for that purpose, to write down the weights. So Na2CO3 combines with 2CH3COOH gives you CO2 plus H2O plus 2CH3COO Na, right? Let me write down the names also. So the first one is sodium carbonate, second one is ethanoic acid. Ethanoic acid is also called as acetic acid, okay, which is present in vinegar. Ethanoic acid, which is also called as acetic acid, which is present in vinegar. CO2 you know carbon dioxide, H2O you know water, and then this is the sodium acetate or sodium ethanoate. Okay, yes, now let us check the weights. So what is the weight of this sodium carbonate used? So weight of sodium carbonate used is 5.3. Yes, weight of sodium carbonate used is 5.3. Weight of ethanoic acid is 6 gram. Okay, and weight of the product side I will write down now. Weight of carbon dioxide is 2.2, water is 0.9 and sodium ethanoate is 8.2 gram, right? Now whenever we are checking for the law of conservation of mass, we check both the sides, weights on both the sides should be same, right? So the sum of the weights of reactants, okay, what is it? 5.3 plus 6, that is equal to 11.3 gram, right? Whereas for products, what is the sum of the weights on product side? It is equal to 8.2 plus 0.9 plus 2.2, it will be equal to, yes, it is also 11.3. It is also equal to 11.3 gram. As both the weights are equal, therefore the reaction obeys, therefore we can conclude reaction obeys the law of conservation of mass, right? So this is how we can solve the question based on the law of conservation of mass, right? Yes, just take a screenshot of this page first of all. Okay, I hope you have taken a screenshot. Now, after studying these two laws, we are going to move to the atom. Now, on the basis of these two laws which we have studied, one scientist whose name is John Dalton, he has postulated a theory on the basis of explanation on the law of conservation of mass and law of constant proportion. He has postulated one theory. This theory is called as Dalton's atomic theory. As this is the theory for atom, it is called as Dalton's atomic theory. Okay, this theory is a result of, or it is on the basis of the two laws, law of mass, conservation of mass, and law of constant proportion. So the name of the scientist who discovered it is John Dalton, who is a British scientist, and he has given some postulates for the Dalton's atomic theory. So let us see what are the postulates of this Dalton's atomic theory. Okay, so the first postulate I will write down. So all these things you already know. All matter is made up of very tiny particles. These tiny particles are called as atoms. Tiny particles called atoms, right? This we know already. Okay, this is the first postulate. Then second I will write down. Atoms are indivisible. Atoms are indivisible particle. Indivisible, the meaning of the word indivisible also I have explained to you in the last class. They cannot be divided further. We cannot cut the atom into two parts according to this. Okay, yes, atoms are indivisible particles. Then third postulate I will write down. Atoms of a given element are identical in mass and chemical properties. What is the meaning of this line? I will tell you. Okay, what is the meaning of this line? I will tell you. For example, if I take the air sample, right? Now in this air so many gases are there, out of which I collect the hydrogen gas molecules. Okay, n number of hydrogen molecules will be there. So all these n number of hydrogen molecules will be made up of hydrogen atoms, right? So let us assume there are 10 to the power 22 atoms of hydrogen in that particular sample. Just assumption. So all these atoms will have same mass, that is atomic number 1, and atomic mass is equal to 1, and they have same chemical properties. Same chemical properties means what? All their reactions will be same, right? All the reactions, that is if it is atom of hydrogen, then its properties will be same, right? It's not like one atom of hydrogen shows one property, another atom shows another property. No, all the atoms of a same elements always will show the same property. That is this postulate. Okay, then fourth postulate I will write down. Atoms of different element have different masses, and exactly opposite to the postulate number 3. Atoms of different element have different masses and chemical property. Okay, yes, so this is exactly opposite to postulate number 3, right? What is the meaning of it? Like again, if I take air sample, right? So in that air sample there are different gases like nitrogen gas, oxygen gas, hydrogen gas, etc. Nitrogen gas molecules are made up of nitrogen atom, oxygen made up of oxygen, hydrogen gas made up of hydrogen atoms, right? Okay, mass of nitrogen gas will be 14, mass of oxygen atoms will be 16, mass of hydrogen atoms will be 1. Okay, all atoms of nitrogen will be same property, of oxygen will have same property, hydrogen will have same property, right? That means atoms of different element, right? Properties of nitrogen atom and oxygen atom will not be same. Same, nitrogen atom, hydrogen atom will not be same. All of them will have different properties, right? So this is the exactly opposite to the postulate number 3, right? If elements are different, their atoms will have the different properties. If elements are same, their atoms will have the same property, right? This is very simple to understand. Atoms of different element are having the different chemical properties and different masses. Then fifth postulate I will write down now. Atoms combine in the ratio of small whole numbers to form compounds. Okay, what is the meaning of it? I'll explain with the help of simple example. H2O, right? So here two hydrogen atom and one oxygen, they combine to form one water molecule. What is the ratio? 2:1, right? So just like water, all other molecules are also formed by combination of atoms in a small ratio, right? Yes, it is very easy. Then next postulate I will write down, the sixth postulate and last postulate. The relative number and kinds of atom, that is types of atoms are constant in a given compound. So last two statements, postulates are on the basis of law of constant proportion, right? Like in water, I have told you this example. Whatever may be the source, all molecules of water from all source, they will have the same molecular formula, that is H2O. Okay, yes. So these are the postulates of Dalton's atomic theory. So just take a screenshot of this page first of all. Okay, I hope you have taken a screenshot of this page. Now after this we are going to see the some more information about atoms, and that is nothing but we are going to see about the size of the atom. Have you ever thought, like, okay, atoms are not visible to open eyes, but what is the size of an atom? Can we compare the size of an atom with some other things, like some other molecules or anything? So that part we are going to discuss now. and that is nothing but size of an atom, or how big are atoms. Okay, yes, so we are going to discuss now how big are atoms. Okay, how big are atoms, let us see. So for that purpose I'm just going to tell you first of all, whenever I'm talking about the size of an atom, size of an atom is expressed in terms of size of an atom is expressed in terms of atomic radius. Okay, atomic radius, as we know that atom is a spherical entity. Atoms are spherical in nature, sphere, just like a ball, right? Therefore atomic radius is used to find out the size of the atom, right? Now atoms are very small, so we cannot take the atom and measure its radius, right? Not at all possible. So how it is done? For that purpose, like we cannot obviously see it by open eyes. For that purpose some complicated instruments are used, like for an example XRD. Okay, it is just one example of an instrument which is used for calculating the atomic size. So it is called as X-ray. X stands for X, R stands for ray, and D is diffractometer. X-ray diffractometer, no need to study it in detail for now. So it is nothing but the instrument used to find out the size. How it is done? Atoms atoms are not free. There are some exceptions of element whose atoms are freely moving in nature, like noble gases, inert gases. But for n number of other atoms, they are not free. They are forming the compound with the other atoms, right? Like almost all atoms are married. Very few of them are bachelor. Okay. So for those married atoms, obviously we cannot separate them and find out their radius. So what is done? So for example, Cl2 molecule. Cl2 molecule is nothing but the chlorine molecule. Okay, Cl is the symbol for chlorine. Okay, Cl2 molecule is the chlorine molecule. Okay, so in this chlorine molecule, two chlorine atoms are connected to each other like this, right? This is one chlorine atom, this is the another chlorine atom. These two chlorine atoms are attached to each other, right? What we know about this? Every atom has the central part. In the structure of atom we have seen this. Every atom has the centrally located nucleus, right? Centrally located nucleus. So these nuclei of these two atoms are connected to each other, and this connection in between them is nothing but a chemical bond, right? Its connection in between them is called as a bond, right? What is this blue line? This bond, blue line, is nothing but a chemical bond in between the two atoms, right? Chemical bond. So by using this X-ray diffractometer, we can find out the bond length. Okay, what we can find out by using X-ray diffractometer? Bond length. Bond length means what? Size of that bond. Now what is the size of that bond? Okay, this is the size of that bond, right? This is a bond length. Now if you observe, this bond length is nothing but 2 times the radius of an atom, right? Can you see? This is the one radius, this is the another radius, right? If I say R, right? This bond length is nothing but 2 times the radius of an atom, right? Okay, so this is one R, this is another R, right? Therefore, how I can find out the radius of an atom? Therefore, atomic radius, this distance I can get by using XRD experiment. Okay, and if I divide that distance by 2, equal to R, equal to bond length divided by 2, I will get the bond, that is atomic radius, right? So this is how the atomic radius is measured, right? This is how atomic radius is measured. Now this atomic radius is measured in terms of the units like nanometer, picometer, etc., angstrom, etc. So what are these units? Only one unit is there for your syllabus. Unit for atomic radius. Unit for atomic radius. Only one unit is there. Atomic radius. I will give you that unit only, and that is called as nanometer. that is called as nanometers. Okay, now for that purpose also there is conversion factor. So 1 nanometer is equal to nanometers. One nanometer is equal to 1 by 10 power 9 meters. Okay, 1 nano, nm is nothing but the nanometer. Okay, m is the meter. 1 nanometer is 1 by 10 power 9 meters, right? Or in another language it can also be called as, it is equal to 10 power minus 9 meters. Okay, 1 nanometer is 10 power minus 9 meter. Or one more I can write down, that is 1 meter is equal to 10 power 9 nanometers. So these are the conversion factors for the unit for atomic radius. Okay, yes, now just do one thing, just take a screenshot of this page. Take a screenshot of this page first of all. Okay, I hope you have taken a screenshot. Now I am going to show you the conversion, or comparison of the sizes of the atoms with some other what you can say species, that is nothing but relative sizes. Okay, so I am going to express it in terms of radius. Radia is the plural of radius. Radius is singular, radia is plural. Radia are given in meters, and here I am going to write down the example. Okay, yes, let us start. So first is radia in 10 power minus 9 meters, and this is the example is the atom of hydrogen. That is hydrogen atom. Next example, next is 10 power minus 9. This is the molecule of water. Size of one molecule of water is in the range of 10 power minus 9 meters. Next is 10 power minus 8, is the molecule of hemoglobin. Hb, the component, red component present in the blood, human blood. Okay, then 10 power 8 is hemoglobin. Then 10 power minus 4, 10 power minus 4 is grain of a sand, one single grain of sand, fine sand. Okay, very fine sand. Then 10 power minus 2, 10 power minus 2 is the size of an ant, 10 power minus 2 meters. And then 10 power minus 1 is the watermelon. Okay, so do you understand? The size of an atom is very, 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 very small. This is the size of an atom. This is the size of watermelon. Is very, very, very small as compared to the size of other particles, right? So this, just a minute. So this table gives us the idea about the sizes. Okay, this table gives us the idea how small the atom is, right? So take a screenshot of this table now. I hope you have taken a screenshot. So that's all for today. So in the next class we are going to see the next things or next concepts related to the atom, like symbols of atom, the IUPAC symbols of atom, Dalton symbols of an atom. So all these things we are going to discuss in the next class. Today we will stop here only. Let us just revise what we have studied today. So this is about recap. Today we have discussed about the Dalton's atomic theory. John Dalton, a British scientist, has given the postulates on the basis of the structure, on the basis of the atoms and molecules. These postulates are on the basis of the observations of the laws of conservation of mass and law of constant proportion. So all these postulates we have discussed in detail. Then we have discussed about the size of the atom, how big are atoms. So I have told you how the size of an atom is calculated. I have also told you about units used for measuring the size of an atom, that is atomic radius, nanometer. Then we have also seen the relative sizes. The size of an atom, hydrogen is the smallest element, okay, only one electron present in it, so its size is also very small, the smallest of all. Therefore its size, which is in the range of 10 power minus 10 meters, that is compared with the sizes of molecule of water, hemoglobin, grain of sand, ant and watermelon. So from all these things it's clear to us that atom is really very small or tiny particle of any matter. So that's all for today. Other things we are going to discuss in the next class. Before ending the class, let me just show you the daily practice problem, that is DPP. So this is a teacher's portal, similar will be the student portal. You have to go to resources, then to the writing material, wherein you can see the DPP, daily practice problem. You can download it here in the form of PDF. We are going to write down the solutions on the paper or notebook. Take a picture of that solutions part, then upload it on the portal. So teacher will review it, evaluate it and let you know the suggestions and corrections in it. Okay, so I hope you understood today's class. If you have any questions related to this session, you can let me know in the tomorrow's class or whenever you find it comfortable to ask. That's all for today. Thank you so much, student, for your precious time, and all the best to you. Take care.